Okay, so I need to integrate this function over this r that's bounded by y equals 0, y equals 2x plus 4, and y equals x cubed. First thing I want to do is I want to draw a picture of this so I get an idea what this thing actually looks like, what this region looks like. Y equals 0 is the x-axis. Y equals 2x plus 4 is going to look something like this. You see this is going to be at a negative 2. It's going to be at 0. X cubed will look like this. And these will intersect someplace. And by look at these, straight by inspection, I don't have to do any algebra. I can see when x equals 2, I get 8, and 2 cubes 8. So this is going to be x equals 2. So this is the point 2, 8. So here's the y coordinate of 8. That means the region that I'm looking for is right here. This is what I integrate over. Now, I could look at this as a type 1 region or a type 2 region, and I'm suggesting the type 2 is going to be easier. If I did a type 1, this is a type 1 region. This is a separate type 1 region. I have to do two separate integrals to do this. So I'm thinking just simply one type 2 region like this would work rather nice. So I'm going to look at it going this direction as a type 2 region. Now, y equals 2x plus 4 implies that x is equal to y minus 4 over 2. That's this linear function right here. And y equals x cubed implies that x equals y to the 1/3, the cube root of y. This is this function. So my double integral is going to be of y squared. Notice that all the manipulation here that I did had nothing to do with this surface. This is z equals y squared. That's this surface that's floating over top of this region. So first, I want to integrate this way with respect to x. So this could be dx. And it's going to go from y minus 4 over 2 up to here, which is y to the 1/3. And then dy, and y is going to go from 0 to 8. So that's what I'm going to be integrating. So like usual, I'm going to grab this piece and work just with that. So if I integrate this, this is going to be y cubed over, oops, I'm sorry, this is with respect to x, my bad. This is y squared x. Evaluator from y minus 4 over 2 to y to the 1/3, which is going to be equal to y squared times y to the 1/3 minus y minus 4 over 2. Now I want to distribute this y squared. So this is going to be y to the 6/3, so I have a common denominator. So this is, when I multiply it through, I'm going to end up with y to the 7/3 minus, this is going to be y cubed minus 4y squared, and both of these are over 2. This 2 is going to cancel and give me a 2 here, and it's minus all of that. So if I want to drop those the parentheses, I can, but I need to distribute that negative. So it's probably easier to think of this as y to the 7/3 minus y cubed over 2. I have a double negative plus 2y squared. And I need to integrate that from 0 to 8. So I will integrate from 0 to 8 of y to the 7/3 minus y cubed over 2 plus 2y squared dy, which will give me, this is going to be y to the 10/3 divided by 10/3, which is the same as multiplying by 3/10, minus y to the 4th over 8 plus 2y cubed over 3 evaluated from 0 to 8. The 0 is nice, so I'm going to be subtracting 0. That's no big deal. So this is going to be 3/10 times 8 to the 10/3 minus 8 to the 4th over 8, which is just 8 cubed, plus 2/3 times 8 cubed. Which I'm not going to fiddle around too much with this. I'm going to let you actually crunch the final numbers. This would be 3/10 times 8 to the 10/3. This is 2/3 times 8 cubed minus 8 cubed. That's one of them. So this is minus 1/3 8 cubed. Whoops, this paren doesn't belong there. Let's get rid of these parens. My bad. That could have been confusing the way I wrote it, because it's 3/10 times this minus that. So anyway, that's a number. You can keep fiddling with it and actually figure out what the number really is. I just grabbed a little piece of technology to figure out what this number is, just so that you can get there. In case you're curious, I end up with 2048 over 15. That's what I ended up with when I crunched some numbers.